Thompson has succeeded in finding one of the memory engrams by tracing the circuitry of the brain involved in conditioning and remembering.
The first goal of the research has been to localize where the memories are stored in the brain. We selected a very simple form of learning, classical conditioning, first developed by Pavlov in Russia, as a model system in which to study where memories are stored. So we mapped through the brain, recording the activity, the electrical activity of nerve cells, looking for places in the brain where the nerve cells generate potentials that relate to the actual learned behavior. What we are showing here is a standard eyelid conditioning experiment using rabbits as subjects. We present a relatively mild neutral stimulus, a tone or a light. We then follow that with a puff of air to the eye, and that, of course, elicits a reflex blink of the eye. And we have just a device hooked up to record the eyelid closure response and a little tube that conducts the puff of air to the eye. With a number of pairings of these two stimuli together, the animal develops a conditioned response, a learned response, a memory, if you will, so that it blinks to the tone before the air puff occurs. After the animal has been trained, we will then make a very small lesion in the region that we think contains the memory trace, and that very small lesion will abolish permanently the memory for this conditioned response. The memory traces for these learned responses that we study appear to be stored in very localized regions right here in this little structure within the cerebellum called the interpositus nucleus. Now, the lesion that abolishes the learned eyelid response is the lesion right here that takes out no more than a cubic millimeter of tissue. In fact, we can abolish any learned discrete movement by a tiny lesion in the appropriate place within this interpositus nucleus. What I'm going to show on the computer face now is the response of the animal early in training before the animal has learned the conditioned response. This is a recording of the eyelid response itself. So time is going this way, tone comes on, and there's no response at all to the tone. Air puff to the eye, a reflex eye blink, eye closure, strictly a reflex before learning has occurred. This is a well-learned conditioned response by an animal that's been well-trained before surgery has been done. The tone comes on at this point in time, and you'll notice that there is a very well-developed eyelid closure response that peaks about the time of onset of the air puff. There is then a reflex response to the air puff itself. This is the conditioned response. After the surgery, we can see that the memory for the learned response is completely obliterated. All that's left is the reflex response, the same response the animal gave at the beginning of training before it had learned a conditioned response. Destroying that tissue permanently abolished the memory for the learned response. The animal could never learn that response again. We can now go after the actual physical chemical processes that are involved in the storage of this kind of memory. So we feel that as we come to understand how the brain stores memories, we will be able to develop new techniques and new tools to deal with memory disorders. So that's a very practical and I think now realizable goal.